Starting from this lesson, we'll start our JavaScript and jQuery study. Using JavaScript, we can manipulate HTML and CSS codes and control web page behavior. For example, we can create a carousel using JavaScript. This is the button we created in our previous lesson, but it doesn't work at the moment. If you want this button to work, you'll need to learn JavaScript. We can also use JavaScript to validate user-submitted data. When you're registering with a website, if the username you pick has already been registered, you'll be told so right away. This is achieved using Ajax. You need knowledge in JavaScript, backend language, and database to achieve that. JavaScript alone is not enough. What is the relationship between JavaScript and jQuery? After you've taken a few JavaScript lessons, you'll start to feel that despite being a powerful and brilliant tool, JavaScript is not very convenient to use. To solve this problem and improve development efficiency, people have developed many products based on JavaScript. All commonly used functions have been integrated. This means you don't have to reinvent the wheel again and again. Your development efficiency will be greatly improved. jQuery is one of those products. At this moment, it's the most popular JavaScript-based product. Many other front-end frameworks have developed with the help of jQuery. Therefore, before you start to learn any front-end frameworks, you're highly recommended to master jQuery first. In this lesson, we'll explore the basic grammar of JavaScript. Every computer language needs a running environment. So does JavaScript. Lucky for us, all JavaScript needs is a browser. First, let's get a taste of JavaScript. Most of you have definitely seen this pop-up window before. It'll tell us certain information and give us a button to click. This pop-up window is created using JavaScript. So our first task today is to create this pop-up window using JavaScript. JavaScript is similar to CSS, meaning you can directly put JavaScript codes into the HTML file, or you can create an independent JavaScript file and link it back when you're finished. First, let's try internal JavaScript. You need a set of style tags for internal CSS. Likewise, you need a set of script tags for internal JavaScript. But the next question is, where should we put the script tag? The best location is at the very bottom of the body tag, directly above the ending body tag. Putting JavaScript codes here can help improve program efficiency. The main job of JavaScript is to manipulate HTML and CSS codes. Therefore, when the JavaScript codes are being executed, all related HTML and CSS must have already been loaded. We have a dedicated thing for that test. It'll hold the JavaScript codes from being executed until everything's ready. But if we put the JavaScript codes at the very end, behind all HTML and CSS codes, then by the time the JavaScript codes are being executed, everything is already ready. The test can therefore be saved, one less function to run, and more system resources can be saved. To create the pop-up window, we need a JavaScript function called alert. This is how you use it. Inside the script, you first write down the function name alert. Behind the name, you put a set of parentheses. Inside the parentheses, you write what you want to say in the pop-up window. Just make sure that you wrap your words using the single or double quotes. If you only want to output numbers, the quotes are optional. We've successfully executed our first JavaScript code. In this lesson, we'll try external JavaScript. First, we create a new file using Notepad++. We set language to JavaScript. Then we move the alert function into the new file. Now remember, just like external CSS, we don't need the tag here. Then name and save the file. And the next question is, how do we link the JavaScript file back? This time, we don't use the link tag. Instead, we'll still use the script tag. First, we add the type attribute and set its value to text/JavaScript. Then we use the src attribute to tell the system where the JavaScript file is. And that's it. We can see the result is the same. Now we know how to create and use both internal and external JavaScript files. Next, let's get to grammar details. Just like HTML and CSS, JavaScript also supports comments. There are two ways you can write your comments. For a single line comment, you start them with a double slash. For a multiple line comment, you start them with a slash and an asterisk. Then you end them with an asterisk and slash. Whatever you write in your command will not be executed. Turn on your Chrome browser and open an empty page. Right-click your mouse, then click the last option, Inspect. You'll see this new page. Go to the top bar and search for a button named Console. Click the Console button and you'll see a page like this. This is a development tool kindly provided by Chrome for free. We can use it to run and test our JavaScript programs. First, let's type some random numbers. Then press the Enter button. After we've pressed the Enter button, Chrome will repeat the number we typed in the next line. Let's try numbers with a decimal point. The same result. If we type a number with 2 or more decimal points, what do you think will happen? No correct numbers will have more than 1 decimal point. As a result, we've got a warning saying something's wrong. So next, let's try some letters. But we've got an error report. If we wrap the letter in single quotes, the error report will disappear. If we try double quotes, the result's the same. So why? The reason we show you this experiment is to introduce you to a very important concept: data type. A computer program is about handling data. Just like a library will divide all books into a different genre, computer languages will use different data types to help manage the data. Different computers have a different rule regarding how data is divided and categorized. For JavaScript, the most commonly used data types are number, string, boolean, array, undefined, null, and object. If you have a background in other languages, you'll be surprised to find that for JavaScript, 8 is the same as 8.0. Most languages will regard 8 as an integer and 8.0 as a float, but JavaScript will treat 8 and 8.0 as the same type, the number type. If we directly input letters, we'll be given an error report. But if we put those letters into quotes, things will be fine. So why? The letters we input belong to the string type. Almost every language requires you to wrap strings in quotes. This is why we need the quotes. So let's go back to the error report. Read it carefully. We're told that what we've just input is undefined. In JavaScript, undefined is also a data type. In the future, you'll actually meet this undefined data type a lot. Boolean type has only 2 values, true and false. In the future, you'll be using the Boolean type all the time. Let's type 8 bigger than 1. Press Enter and we get true. This is because 8 is bigger than 1 is a correct statement. If we type 8 is smaller than 1, we get false, because 8 is bigger than 1 is a false statement. Null means empty, non-existent. It has only got one value, null. So far, we've learned 5 data types: number, string, undefined, boolean, and null. So here comes a question. What would happen if we did comparisons between data types? The first thing you should learn is how to do comparisons. In your maths class, this sign means equal to, but in computer language, this sign means value assignment. You'll learn about this later. If you want to express the meaning of equal to in computer language, you'll need 2 equal sign or 3 equal sign. 2 equal signs only compare values, and 3 equal signs compare both value and data type. For example, we type a number 8 and a string 8. If we put 2 equal sign between them, we'll get true. If we put 3 equal signs, we'll get false, because 8 is number type, but 8 in quotes is string type. Computer language is about handling data. To better process data, people have developed a container to hold them. JavaScript has 2 types of containers: variable and array. Different languages have different rules regarding how to create a variable and an array. In JavaScript, if you want to create a new variable, you first need to type the keyword var. JavaScript is very strict with letter case. The keyword var must be in small case. Behind the keyword var, you type the variable name. The variable name is picked by you, but can only use underscore, letters, and numbers. And besides, you can't start a variable name with numbers. You cannot name your variable new either. This name has been occupied. Variable name is case sensitive. At this moment, the variable we've declared doesn't have any value stored to it. To assign value to a variable, you use the equal sign. You can actually declare a variable and assign value to it simultaneously. After you've assigned value to a variable, you can directly use the variable to represent that value. You can also override the original variable with a new one. All you need to do is do the value assignment again. The old value will be replaced by the new one. You can also do value assignment between variables. The variable on the left side will have its original value replaced with value from the variable on the right side. One of the most important applications of variable is to work as a counter. In the following lessons, you'll learn a very important technique called loop statement. The strength of a computer program largely relies on loop statement. Basically, loop statement works like a repeater. It'll keep executing the same codes again and again. To make that repetition controllable, we need a counter to record how many repetitions have been executed, so that we would know when to shut the repetition down. This is the basic structure of a counter. We increase or decrease the variable value by 1 every time a repetition has been executed. To make our code more concise, there's a shortcut here: ++ or -. For example, we declare a new variable counter. We set its original value to 1, then we type counter ++, and now the value of variable counter is 2. In this lesson, we'll learn one of the most important pillars of computer languages. I mean all computer languages, not just JavaScript. This pillar is called the if statement. The if statement gives our program the ability to make decisions. Different languages have different rules regarding the format and the grammar rules of the if statement. For JavaScript, this is how you write the if statement. First, keyword if. Then a set of parentheses and a set of curly brackets. At the end of the curly brackets, you can add another keyword, else, and another set of curly brackets. If the condition is true, the codes inside the first curly brackets will be executed. If the condition is false, codes inside the second curly brackets will be executed. But remember, both null and number 0 will be regarded as false, but string 0 will be regarded as true. Sometimes we might need to make decisions based on the value of a variable. The if statement can still meet our demand here, but it's just not very convenient. Therefore, we've got a better option: the switch statement. The switch statement follows a fixed pattern. Inside the curly brackets, you can put the keyword case, then variable value, and a set of colons. On the next line, you put the codes to be executed if this condition has been met. At the end, you put another keyword, break. As long as you've got enough variable values, you can keep repeating this case break part. At the very end, you can add another keyword, default. If none of the previous conditions have been met, codes behind the keyword default will be executed. We've learned one of the pillars that make a computer program powerful. In this lesson, we'll learn another one. Remember, we've taught you how to create a counter using a variable and two plus or minus signs. You'll need it in this lesson. Let's say we want to create 100 pop-up windows. How do you do that? Copying and pasting the alert function for 100 times is a solution, but it's not a very good one. The best solution is loop statement. There are two kinds of loop statements: while and for. Let's start with while. The structure of the while statement is the same as the if statement. Keyword while first, then a set of parentheses and curly brackets. Inside the parentheses, you put the condition, and inside the curly brackets, you put the codes to be repeatedly executed. Usually, the condition is the counter. As long as the counter is within certain range, the codes inside the curly brackets will be repeatedly executed. Inside the curly brackets, behind all the codes we want to be repeatedly executed, we need to either increase or decrease the value of the counter variable by 1. This is to mark that one repetition has been executed. At this moment, the program is kind of like an internal combustion engine. It has all the components it needs to run, but it just can't start itself. On a car, we use an electric motor to start the engine. The equivalency of an electric engine here is the initial value of the counter variable. Usually, we set its value to 1. Now we've got a complete while statement. Let's say that we want to create 10 pop-up windows. We first declare a variable counter and set its value to 1. Then the while statement. Inside the parentheses, we set the condition. Variable counter smaller than or equal to 10. Inside the curly brackets, we first put the codes we want to repeatedly execute, and here we put the alert function. After the alert function, never forget to mark each repetition. Variable counter plus plus, and now run the program. We can see the pop-up window will be popping out for 10 times. Next, let's make an improvement to the program. We want to know the index of the pop-up window. Simple. We put the variable counter into the parentheses of the alert function. While statement is the most commonly used loop statement, but not the only one. We also have the for statement. The grammar structure of the for statement is quite different from the while statement. We need to put the whole counter system inside the parentheses. The first part is the initial value of the variable counter. The second part is the condition, variable counter smaller than or equal to 10. The third part is variable counter plus plus. Between each part, you put a semicolon. And remember, it's a semicolon, not a comma. Variable is a container for storing value, but it can only store one value at a time. This is not enough. We want a bigger basket. The bigger basket is called array. Creating an array is very simple. You gather all the values you want to store and put them into square brackets. Between each value, you need a comma to separate them. Each value stored in an array is also called an array element. But an array like this is not very convenient to use. Usually, we'll assign it to a variable. The variable works as a handler, which can help us operate the array and all values stored inside it. The name of this variable will also be the name of the array. Every array value has an index. Using this index, we can locate each value accurately. But remember that index starts at 0, not 1. If you want to get the first array value, the index you need is 0, not 1. Index 1 will get you the second array value. Apart from retrieving array element, the index has also allowed us to change array element value. All we need to do is pick an array element using its index and assign a new value to it. This new value will automatically replace the old one. During our previous lessons, we've been using a function called alert in class demonstrations. In this lesson, we'll learn what function is and how to use it. A function is a bunch of codes assembled in order and can complete certain tasks for us. There are three kinds of functions: built-in function, self-defined function, and anonymous function. The alert function we've been using is a built-in function. The value we've been putting into the parenthesis is called function argument. Different functions have different requirements for function arguments. Some may need one, others may need more than one, and some may need none at all. The most important thing about setting function arguments is the order. Functions distinguish their arguments only by one standard: the appearance order inside the parenthesis. You must make sure you've got the order right. This rule applies to all computer languages, not just JavaScript. In the following PHP lessons, you'll hear we emphasize this regard again and again. Built-in functions alone are not enough to meet all your demands. Sometimes you need to create your very own functions. First, you type the keyword function. This is to tell the system that a new function is about to appear. Then you pick a name for the new function. Now regarding function names, you can still only pick from letters, numbers, and an underscore. You can never start your function name with numbers. Apart from that, your function name cannot be the same as built-in functions. And after the function name is set, a set of parentheses and curly brackets. Inside the parentheses, you declare all function arguments that the function needs. But remember, we don't need the keyword var here. Inside the curly brackets, you write all your codes. After you've declared a function, if you directly run the program, nothing will happen. Because declaring a function is just the first step. The function will not be executed automatically. You need to call the function you declared. Calling a function is basically the process of assigning values to function arguments. You need to write down the function name first, so that the system will know which function you're calling. Inside the parentheses, you provide argument values. You must make sure the argument value is provided in the correct order. The order is everything. Creating an anonymous function is almost identical to creating a self-defined one. The only difference is we don't need the function name. But actually, anonymous function is very useful. You'll be using it a lot in the future. If we want to know how many values an array has, what should we do apart from counting them ourselves? It's simple. You just need to put a dot and the word length behind the array name. So here's a question for you. What is this dot and length? JavaScript has a built-in function called typeOf. Using it, we can get the data type. But what do you think we'll get if we use the typeOf method to test the array? Well, the result we get is object. Just like functions, there are two kinds of objects: built-in object and self-defined object. The array object we've just got is a built-in object. So what is an object? Well, an object is kind of like a factory. It can fulfill certain tasks for us. It's like an enhanced version of function, only much more powerful. As mentioned before, computer programs are used for processing data. So is object. To process data, we must first be able to get the data in and out of the object. This transportation job is done by object property. Property is actually a variable, but it can only be used by an object. Length is a number of the array object. It can tell us the total elements number. The transportation job is done by object properties. So who will be responsible for processing that data? The object's own private functions. Actually, we have a name for those private functions: methods. Since property is actually a variable and method is a function, what's the difference between them? Well, you can directly use a variable or a function, but you cannot do this with properties and methods. You must specify which object they belong to first. This is why before the length property, we put a dot and the object name. The dot is for connecting the object and its methods and properties. A different language has a different rule in this regard. For example, PHP doesn't use a dot. Instead, it uses a dash and a right bracket. We've tried the length property of the array object. Next, let's try its methods. A method is actually a private function of an object. Just like an object property, we need to connect the object name and the method name using a dot. The first method we're learning is called push. Using it, we can add a new value to the end of an array. If we can add a new value to the end of the array, we can also remove the last value from the array as well. To do that, we use a method called pop. Now remember, the pop method does not need any arguments. You just need to keep its parenthesis empty. If you want to remove the first array element, you should use the shift method. But still, you need to keep the parenthesis empty here. If you want to add a new element to the beginning of an array, you should use the unshift method. And if you have an array value but you want to know its index, you use the indexOf method. But remember, the letter O needs to be capitalized. The array object created a bridge linking us and the array. With its help, we can manipulate the array easily. In this sense, this object array is like an API, application interface. It's like a bridge linking us to the array. The communication is therefore much easier. In the following lessons, you'll learn how to operate page elements. Operating page elements means operating HTML and CSS codes. But operating another file, especially when that file is created using a different language, is never a simple task. This is why we need help from another built-in object, document. With its help, we're saved from the trouble of building the bridge. Many people find it hard to understand the concept of object-oriented programming. If you search the internet, it's also quite hard to find a satisfactory explanation from there. Our suggestion is, there is nothing to understand about object-oriented programming. Just accept it and follow its rules. This is kind of like driving a car. You don't need to be a mechanic to drive a car, you just need to know the rules and make sure you follow them. An object can help us complete certain tasks. We don't need to know how the object works inside, we just need to know its properties and methods. We've tried the array object. Starting from this lesson, we'll learn another built-in object, the document object. Actually, the document object is the reason why JavaScript is the best candidate for manipulating HTML and CSS codes. Manipulating HTML and CSS codes is quite a big task. Therefore, the document object is a rather complicated object. It contains many properties and methods. Some of its properties are also objects with their own properties and methods. The first method of the document object we're going to learn is write. Like we said before, always connect method name with object name using a dot. The write method can help us output content directly into the browser window. Thanks to the document object, we now have a bridge directly linking our JavaScript codes with the HTML codes. Our command can be swiftly interpreted and sent to the HTML file. The key to accurate control is accurate selection. Therefore, before we learn more about the document object, we need to learn two new concepts, node and DOM tree. First, what is a node? Open a HTML and everything you see is regarded as a node. A h1 tag is a node, a DVI is a node, a comment is a node, even an indent is a node as well. If your HTML has unwrapped text, which we strongly oppose, then the unwrapped text is also a node. Next question. What's the difference between page element and node? A short answer would be, you must know the difference. It's very important. All page elements are nodes, but not all nodes are elements. In other words, page element is just one node type. There are many other types of nodes. From this chart, we can see there are 12 different types of node. Element node is type 1, text node is type 3, and comment node is type 8. So the conclusion is, page element is a type 1 node. The main job of JavaScript is to control page appearance. Usually, you only need to operate page elements or type 1 node. DOM tree describes the relationship of each type 1 node. If you want to select page elements accurately, then DOM can be very helpful. The HTML tag is the trunk. The head and body are the two main branches, and all page elements inside the body tag are further branches. Starting from this lesson, we've officially entered a new stage of our JavaScript study, DOM operations. In this stage, we'll only be learning one thing, the document object and its properties and methods. The document object is a very big object. It contains many methods and properties. Even some of its properties are objects as well. Once again, whenever you're using a method or property, make sure you connect them to the object they belong to using a dot. In the following lessons, we'll often deal with two or more objects simultaneously. Sometimes, different objects share the same method name and property name. Always make sure you have a clear idea of which object you're dealing with. Never mix objects. Our main DOM operations are retrieving contents of selected page elements, changing contents of selected page elements, changing CSS settings of selected page elements, creating new page elements, putting new page elements to the place we want, removing selected page elements, form validation, etc. All these operations are built on the same foundation. We must be able to select the page element we want to operate. Therefore, we'll begin our DOM study with how to select. There are two kinds of URL, absolute URL and relative URL. Likewise, there are two kinds of selections, absolute selection and relative selection. In CSS, we'll select a page element using their ID, class and tag name. This is called absolute selection. Most of the time, absolute selection can meet our demands, but most of the time does not equal to all the time. Sometimes, due to a certain reason, the destination we want to reach might not have a clear address. For example, we've got a UL list here. We want to get to the second list item. Only the UL tag has an ID. In this case, we need to reach the UL tag first. From there, we make our next move. This is called relative selection. We'll learn about this in detail later. First, let's start with absolute selection. The first method we're learning is called getElementById, and it belongs to the document object. JavaScript is very sensitive with letter case. Therefore, make sure you've capitalized the right letters. Whenever you're using a function or method, you should also be clear with what kind of value it returns. The getElementById method will return as an object. This object represents the selected page element. Just like the whole web page is represented by the document object, each page element is represented by its own object as well. That object is the bridge between us and the selected page element. Because of it, we can operate that selected element. Attention! Just like what its name is suggesting, the getElementById method only selects page element or type 1 node. So let's try what we've learned. The HTML file we've got contains several page elements. Each element has got its own ID. Let's try the getElementById method on this file. We can see the getElementById method can return as the selected page element. But what if the ID we provide does not exist? Well, we'll get null. Selecting page elements is just step 1. There'll be further operations on the selected elements. For our own convenience, we'll usually create a new variable to receive the object returned by getElementById. At this moment, we've got two objects. The document object representing the whole web page and the returned object representing the selected page element. If we want to further operate the selected element, the new object will take over from document object. If we selected 2 page elements, we'll get 3 objects. It's very important you maintain a clear idea of which object you're dealing with or need to deal with. After we've selected a page element and received its object, we can start to operate that page element. Operating the selected page element requires methods and properties from the object representing the selected element. First, let's try to retrieve information of the selected element. Retrieving information is usually the job of properties. Let's select a p tag using getElementById. Let's say we want to retrieve the text wrapped in it. The solution is the innerText property. Now remember, the innerText property belongs to objects representing the selected page element. The innerText property is actually a two-way road. Using it, we can retrieve information as well as adding new information. If we want to change the text wrapped in the p tag, we can assign new values to the innerText property. The old value will be automatically overridden. What if we selected a UL tag and want to list every LI tag in it? In this case, we cannot use innerText anymore. We need innerHTML. Likewise, innerHTML can also be used to switch contents. The p tag and the UL tag are both double body tags, which means their contents are wrapped inside them. What if we're dealing with a single body tag like the img tag? For example, what if we want to retrieve the from the img tag? The solution is simple. We use the alt property. Still, the alt property belongs to the object representing the img tag, and also the alt property is a two-way road. Every attribute of the img tag has a corresponding property, including the src attribute. This has opened a door of great potential. This means we can switch image files from JavaScript. Apart from retrieving and editing contents and HTML attributes, JavaScript can also retrieve and edit CSS settings. This requires help from the style property. In terms of data type, the style property will give us an object. This object contains all CSS settings. As a result, another door of great potential has been opened. We can add new CSS settings, we can change the current CSS settings, we can also make an element disappear. Now all of you have experience filling online forms. If the information you provide is unqualified, you'll be notified right away. This is called form validation. The foundation of form validation is to retrieve user-submitted data. This is actually very simple. First, we get the object representing the input tag. Then, we can get what we want from the value property. Very simple. We've now experienced the power of JavaScript and the document object. Next, let's continue our element selecting study. Just getElementById is not enough. If we can select element by its ID, we can also select it using its class and tag name. But there's a big difference between ID and class or tag name. ID is always unique, but class and tag name are not. This is why the word elements is in its plural form, getElementsByClassName, and getElementsByTagName. getElementsByClassName is a newly added method. It didn't exist a few years ago. After years of eager anticipation, it's finally here. The result returned by the two getElements methods is different than the one returned by getElementById. We can still get an object, but that object is also an array. For example, we can select all li tags using the getElementsByTagName. But if we want to retrieve information from one li tag, we need to locate it using the index. Otherwise, the inner text property won't work. Even the UL list has only one list item. You still need the index. Apart from all the getElement methods, we also have two querySelector methods. They are querySelector and querySelectorAll. When setting argument values, make sure the ID has its hashtag and class has its dot. The difference between the two methods is querySelector will return you the first element matching the searching condition. querySelectorAll, however, will return you every matching result. Therefore, when you're using querySelectorAll, make sure you remember to add the index. We've tried the absolute selecting method. Next, let's try the relative one. Before starting the following lessons, once again we need to review the difference between page elements and nodes. Page element is a type 1 node. All elements are nodes, but not all nodes are elements. Take a look at this example. We've got a UL list. This list has 3 list items. For a certain reason, only the UL tag has an ID. If we want the first li tag, what should we do? First, we go to the UL tag using getElementById. This is where the DOM tree is particularly helpful. The first li tag is the first child element of the UL tag. Using a property called firstElementChild, we can retrieve the object representing the first child element. Apart from firstElementChild, there is another property called firstChild. There is a big difference between these two properties. FirstElementChild will only select type 1 nodes, but firstChild will return any node as long as it's ranked as the first one. If we try firstChild here, we will not get the first li tag. Instead, we will get the empty text node representing the white space between the starting UL tag and the first starting li tag. Let's prove this. We can see after we have switched firstElementChild to firstChild, we get a different value. #text. #text means empty text node. Each node object has a property called nodeType. It can tell us the node type. We can see the result from the firstChild property is type 3, but the result from the firstElementChild property is 1. If we add the comment immediately behind the starting UL tag, the result from the firstChild property is 8. Type 8 node is comment node. If you want to know the total child element number, you ask the child element count property. If you want to know the total nodes number, you first need the child nodes property. The child nodes property will give you an object representing all nodes. The new object has a length property, which can tell you how many nodes are inside. We can see, due to all the indents, there are more nodes than elements. If we remove all the indents, the two values will be the same. If we can select the first element or node, we can also select the last one. Still, last element child gives you the last element and last child gives you the last node, regardless of node type. But what if we want to get a second list item? Simple, we get the UL tag first. From there, we get the first list item using first element child. The second list item is the next sibling of the first list item. Using the next element sibling property, we can reach the second list item. If you're interested in the node behind the first list item, you can use next sibling. Apart from next element sibling and next sibling, we've also got previous element sibling and previous sibling. The list we use only has 3 items. What if it's got 300 items and we want to use the one in the middle? In this case, the best solution would be the children property. This property will return you an object containing every child element. You can use index to locate the specific element you want. If you're interested in nodes, you can also use the child nodes property. Starting from this lesson, we'll learn how to create new page elements and insert them to the exact place we want. We've got 2 things to do here: creating a new page element and inserting that new element to the desired place. Creating a new element also means creating a new page element object. We need the createElement method for this job. Naturally, the createElement method belongs to the document object. The argument value of the createElement method is the name of the HTML tag you want to create. After you've created the empty HTML tag, next you need to fill it with all the necessary attributes and contents. For example, we want to display an image using JavaScript. First, we need to create an empty img tag. After we've got the tag, we need to set its src and alt attribute. After we've created an empty img tag, we need to use the src property to set the URL of the image file. Then we need the alt property to set an extra safety net. We can also add the title attribute using the title property. The UL tag is used to house all its child li tags. This means after we've created a new empty UL tag, we need to insert child elements into it. Now remember, the list items are text wrapped in li tags. This means each list item is a page element or type 1 node. A list item is not a text node. We need the inner HTML property for this job. p-tag is mainly used for wrapping texts. After we've created a new empty p-tag, we only need to insert plain text into it. The best option here is inner text. Make sure you know the difference between p tag and the UL tag. We are adding elements or type 1 node into the UL tag, but for the p tag, we're only inserting text or text nodes. Remember, text wrapped in HTML tags are elements or type 1 nodes. Unwrapped texts are text nodes. Those are two different nodes. Actually, there's another method we can use to insert text into the p tag. Compared with the inner text option, the new method is rather inconvenient. You will never use it, but you will benefit from learning it. Like we've repeatedly emphasized, unwrapping text is a text node. Therefore, we can create a text node and insert that node into the p tag. Creating a text node requires the createTextNode method. After we've created the text node, we should insert it into the p tag. The solution is the appendChild method. Like we said before using any methods, make sure you know which object it comes from. The appendChild method does not come from the document object. It belongs to the object representing the p tag we just created. Make sure you remember this. We can see the p tag now has text wrapped inside it. In this lesson, we'll learn how to insert new page elements into the selected location of the web page. To insert a new page element, we can use the appendChild method, but it can only put new elements to the very end. If we want to control the location of newly added elements, we need to use the insertBefore method. This is the definition of the insertBefore method. Read it carefully, at least 3 times. The insertBefore method is used to insert a new node. The selected node is a child node of the current node. The object owning the insertBefore method should be the parent of the node to be inserted. This information is particularly important. Let's say we selected the li tag and we want to add a sibling li tag to it. First, we need to go from the selected li tag to its parent, the ul tag. To get to the parent, we can use the parentElement property. After we've got to the object representing the parent element, we can start to prepare the insertBefore method. The insertBefore method has 2 arguments. The first one is the object representing the new element. The second one is the reference node. The new element will be inserted before it. Therefore, before using the insertBefore method, make sure you've created an object for the new element using the createElement method. Let's say we want to add an extra list item to the list and want the new item to be the first one. First, we create the new list item. Then we select the first li item using its ID. From the first li tag, we go to its parent using the parentElement method. Next, we call the insertBefore method and 2 arguments to set. The first argument is the object representing the new list item. The second argument is the reference node. And we can see the new item has been added to the exact location we want. If we can add new page elements, then we must also be able to delete them. Most importantly, we want to be able to delete any element or node we want. The solution is the removeChild method. The removeChild method will remove all types of nodes, not just limited to type 1. The removeChild method only has 1 argument, the object representing the node to be removed. Judging from the method name, we can see that just like the insertBefore method, the object owning the removeChild method is the parent of the node to be deleted. Let's say we have a div here, and we want to delete it. First, we locate the div using its own ID, then we use the parentElement property to reach its parent. After we've got the parent's object, we can call the removeChild method. The argument value of the removeChild method is the object representing the node we want to delete. In summary, after you've selected a page element, whether you want to add sibling elements for it or delete it itself, you need to use the parent element property to get to its parent first. Whether you're using any methods or properties, make sure you connect them to the right object. We've got another UL list here. Let's say we've selected the UL tag by its ID and want to delete its first list item. The best solution would be using the first element child property to do the selection. We can see it worked. The first list item has been removed. Then let's copy and paste the code we used to delete the first list item and see what happens. We can see the second item is gone. If we continue to repeat this process, we can eventually empty the whole list. If we switch the first element child property into the last element child property, we'll still get the same result. When removing list items, we have only been selecting the first item. So how can we eventually empty the whole list by only deleting the first item? After we've removed the first list item, what will the original second list item become? I'll show you. If we want to delete every list item, we just need to keep deleting the first item or the last item. In the last lesson, we've deleted a list manually. In this lesson, we'll do it automatically. To empty the whole list, we just need to keep deleting the first or last list item. The only problem is, we need to find out how many repeats we need. How many repeats we need depends on how many items the list has. To get the item total number, we use the child element count property. If we need to repeat the same operation for a fixed number of times, who should we ask? We ask the loop statement. As usual, whether we need to use the loop statement, we need to create a variable to work as the counter. First, we create a new variable counter and give it an initial value of 1. Then the while statement. Inside the parentheses, we put the condition, counter smaller than or equal to the total number of list items. Inside the curly brackets, we just keep deleting the first or last list item. In the next line, we add 1 to the value of variable counter to mark that one repetition has been completed. Now we can see the list can be automatically deleted. At this moment, using our JavaScript knowledge, we can create and delete page elements, retrieve and alter element contents, and change CSS settings. But the problem is, all these operations can only happen manually. For example, using JavaScript, we can control the appearance and disappearance of these list items. But we don't want to control that ourselves. We want our users to have that control. For example, on the top of the list, we put a button. We want the list to disappear in the event of the button being clicked. We also want the list to return when the button's been clicked again. Controlling the timing of JavaScript codes being executed is called event. Event describes certain user operations. Clicking a button or page element is an event. Putting a cursor above a certain page element without clicking it is another event. Moving the cursor away from a page element is also an event. Filling a form is an event. Submitting a filled form is an event as well. Well, actually, a whole HTML being loaded completely is an event as well. Every event has an owner. Getting the object representing the owner is the first step of using event. For example, we've got a button and a list. We want the list to disappear when we click the button, and we also want the list back by clicking the button again. The event owner here is the object representing the button. First, we need to select the button using the getElementById method. Then, we need to get its onClick property. Now remember, it's onClick, not just click. All letters are in small case. Then we need to assign a function to it. Now remember, we're assigning a function this time, not a value. For now, we'll try the anonymous function. We'll deal with the predefined functions later. Defining an anonymous function is very simple. You only need the keyword function, a set of parentheses, and a set of curly brackets. Nothing else is needed. All the codes should be placed inside the curly brackets. To make this button work, we first need to check the display status of the list. The UL tag is enough to represent the whole list. First, we select the UL tag, then we get its style property. From the style property, we get the display property, then we check its value. If the display property's value is none, we switch it to block. Otherwise, we switch block into none. We can see the button is now working. We click the button, and the list will be gone, and we click the button again, and the list will come back. We've tried the anonymous function, now let's try the self-defined function. Creating a self-defined function is simple. If you don't remember how to do this, review previous lessons. After the function's done, we assign its name to the onClick property. Now remember, we only need the function name. Do not put the parentheses. And we can see that the result is the same. But we do have a problem here. What if our self-defined function needs argument values? If we're not allowed to keep the parentheses, how do we pass argument values into the function? In this case, we need help from the anonymous function. If we put our self-defined function inside the anonymous function, we can pass argument values. Until now, we've been putting the script tag and all JavaScript codes inside it at the very end, behind all the HTML codes. Actually, this is a very good arrangement. You're strongly recommended to follow it. But remember that we said completely loading a web page is also an event. If you need to put the script tag in the head area, then you cannot just directly put your JavaScript code into the script tags anymore. We need to hold all JavaScript codes from being executed until the whole web page has been loaded. This is why you'll often see many people begin their JavaScript codes with window.onload. But remember, the onload property belongs to the window object, not the document object. Behind window.load, there's an anonymous function. All their JavaScript codes are stored inside that anonymous function. This can guarantee all JavaScript codes will only be executed when everything is ready. As a result, we can put our JavaScript codes anywhere we like. We still recommend you to put all your JavaScript codes at the very end. In this way, we don't need to check if everything's been loaded. One less bit of work to do. More system resources can be saved. In the previous lesson, we've learned how to add event to selected element, but we can only add one event to one page element at a time. What if we've got several similar elements and we want to add the same event to them simultaneously? Are there any shortcuts? The shortcut is a new method called addEventListener. Before using any methods, we must first know its object. So who is the object of the addEventListener method? The parent. For example, we've got several img tags wrapped directly inside a div. If we want to add the same event to all these img tags simultaneously, the object owning the addEventListener method should be the one representing the div. Likewise, if we want to add the same event to all list items, the ul tag is what we should select. Just like the insertBefore and removeChild methods, the addEventListener method operates on child elements from the parent level. This has also proved the importance of a well-designed HTML code. After the object of the addEventListener method is selected, next we need to take care of its arguments. We've got 3 arguments to set. The first one is event name. But unlike what we did in the previous lesson, we only need the event name here. For example, we only need click, not onClick. The second argument is the name of the function we want to bind. We only need function name here, don't keep the parenthesis. The last argument only accepts Boolean value. For now, we keep it to the most commonly used value, false. Let's try the addEventListener method. We've got a list here. Let's say every time we click one of the list items, we want to keep a record on the console table. First, we create a self-defined function and name its record. Inside the curly brackets, we call the console object and its log method. Next, we call the addEventListener method. First, we need to get the object owning the addEventListener method. The object we need is the parent, which is the ul tag. We select the ul tag using the getElementById method. Now we've got the object. Then we call the addEventListener method. 3 arguments to set. The first one is event name, click. The second one is function name, record. The third one is set to false. Refresh the page and turn the console table. We can see every time we click a list item, there will be a record shown on the console table. We can see, using the addEventListener method, we can bind the same function to several elements simultaneously. This can save us a lot of work, but we've also got a problem. Let's say every time we click the list item, we want to output the content of the clicked item. The challenge is, how do we get the object representing the element currently being clicked? The solution is the event object and its target property. The event object can help us direct which page element is currently being clicked or evented. The target property can bring the object representing the element being clicked. Now let's do an experiment to prove what the event object and its target property can do. First, we select the first list item. Then we call its onClick property and assign an anonymous function to it. Inside the anonymous function, we retrieve the content of the first list item using the innerText property. Then we use the log method from the console object to output the content. Click the first list item and we'll get its content on the console table. Next, we remove the innerText property and try the event object and its target property. We can see the result is still the same. This means the target property from the event object can also bring us the object representing the selected page element. This has also proved another statement. You can get the same object from different sources. The cooperation between the event object and the addEventListener method has also opened a door of great potential. Using the event object and its target property, we can get the object representing the selected page element. In this lesson, we'll explore the last argument of the addEventListener method. Let's create two divs, one parent div and one child div. If we ID the parent div UK and the child div London, if we entered UK, we're not necessarily in London, we might be in other cities. But if we entered London, we're definitely in the UK, because the UK contains London, and London is part of the UK. If we selected London, then the UK is definitely selected as well. Let's create a function called Welcome to UK. Inside the function, we use the log method from the console object to output a text, Welcome to UK. Then we use the addEventListener method to bind the Welcome to UK function to the UK div. We set the first argument to click. As for the third argument, we'll still keep it to false. If we click the UK div in our console table, we'll get a record, Welcome to UK. Even if we click the London div, we'll still get the same record, because London is part of the UK. Clicking London also means clicking UK. Next, we'll create another function, Welcome to London. Then we bind the Welcome to London function to the London div using addEventListener. Then let's click the UK div but avoid the London area. We've got Welcome to UK. Then let's click the London div. This time we've got two records, Welcome to London and Welcome to UK. And Welcome to London comes before Welcome to UK. Remember this order, you'll need it later. The reason we've got two records is because London is part of the UK. Clicking London also means clicking UK. Therefore, if we click London, we'll trigger not only the Welcome to London function, but also Welcome to UK function. This result is called propagation. Usually, propagation is not a desirable feature. For example, we only want Welcome to London when we click the London div. We do not want the Welcome to UK. So how do we get rid of this propagation effect? To get rid of the propagation effect, we just need to call the stopPropagation method. This method belongs to the event object. But the problem is, where should we put the stopPropagation method? Inside the Welcome to UK method or inside the Welcome to London method? We've emphasized that after we've clicked London, we'll first get Welcome to London and then Welcome to UK. This means the Welcome to London function will be executed first. Therefore, if we don't want Welcome to UK to show up, we need to put the stopPropagation method into the Welcome to London function. After Welcome to London has been output, the stopPropagation method will be called to stop the propagation. We can see if we click London now, we'll only get Welcome to London. The third argument of the addEventListener method has always been set to false. In this lesson, we'll figure out what the third argument does. In essence, the third argument controls the direction of how an event is passed. If we set it to false, the event will go from child to parent. This means the function bond to the child will be executed first. Then the function bond to the parent will be executed. This process is also called bubbling, just like a bubble going from bottom to top. If we set its value to true, this means the direction will be switched from parent to child. This means if we click London, we'll get Welcome to UK first. But this has also brought us a new problem. With the third argument being set to true, it's impossible for us to only get Welcome to London. Welcome to UK will always be the output, because parent will come before child this time. Therefore, the Welcome to UK method will always be called first. This is why most of the time the third argument is set to false.